to go for something else. And it refuses to work, cannot be preloaded. Anyone sees what I'm doing wrong? One? A bit too much. But actually I can just cheat and use the stuff I did yesterday, which is about the same. It's ignoring it too. So I didn't change anything in my system and it's ignoring my library.
Was any
Lib freeload too?
How did you name the library?
Yeah, I compiled this one yesterday, so I have 2 SO files in there, or actually 3.
Yeah, I mean the one you used just now is libreload 2.
Yeah, but well, I tried this one before, but it. Sorry? Absolute path for the library. All right, good point. And we see that real malloc is getting called. And we have learned something, so we need to use an absolute path. I don't remember that I did this yesterday, but so we have done the first thing to have a custom allocator. We just need to define the functions we want to change and remember the real name of them and then call it. So the next thing is to generate a backtrace, and because I don't think I have so much time, I'm just going to show you the ways of generating a backtrace. And let's. So on glibc systems to generate a backtrace, we can use a built-in function in glibc called backtrace or backtrace symbols. And to make it work on ARM, you need to compile your application with -f no omit frame pointers. Otherwise, the system doesn't know where a frame ends or stops. On x86, you don't face the same problem. Or if you're using GCC, you can also use like one of the built-in functions to give you the frame address and the return address of a stack frame. Or I think there's called a library called libbacktrace, which works on many platforms to allow you to generate a backtrace as well. Or if you're really fancy, you can do it yourself and try to walk the stack. Just figure out the stack layout and find the return pointer and walk the frames. Yeah, but once we have walked the frame, we have a list of, actually I think, say program counters, but in this case we're going to have the pointers to the text segments. And so I have a simple application. Let's go through the functions first. The first one is called generate backtrace. It's getting called from bar, and the function foo calls bar, and bool calls foo, and finally someone calls things. So I try to generate some calls to have a stack trace. And inside the backtrace, at first we're using glibc as a simple feature to generate a backtrace. Just allocate a buffer of void pointers and tell glibc how many void pointers we have, and then iterate over the list we got back and print them. The next one is to use symbol names. So if you have enough debug information, glibc actually can print out the function names itself. And finally, we're using the GCC feature to give us the address of the call frames. So actually, we know where we return to. So if I compile with debug information, it's called to. If I compile with debug information, we're actually seeing with glibc plain functions, we see the address of the text segment and where it was. With symbols, it actually only knows the binary name, but not the function name. There's a special GCC function to generate more information, and we could even see the function names inside the binary, and with the GCC built in, we actually see the same address for return address. So we have many ways to generate a backtrace. But if I give you an address, you actually don't know which function was called. So does anyone know how to get the file name and line number from an address of your text segment? No? Anyone? You probably do. Oh, another application from BinUtils. Another one. No, it's just actually a really simple thing. Address to line. We tell it, or actually, it's very simple. You pass it the application, you tell it that you want to have the function names, and you finally give it the address. So we want backtrace 2. And we want to know which function is this, and so it tells us it's backtrace C and line 38. I've never verified it works, but yeah, so it figures out it was bar who called this thing. So now we have 3 things. The first one is we know how to intercept calls to malloc. We know how to generate a backtrace. The next thing that we actually need to do is translate names, like the point or the address to a name. And in memprof, you're using like libbfd from BinUtils to do this. It also can demangle C++ names into names normal people can read. But I'm not going to show this part. So yeah. So with libbfd, one can translate the address back to a meaningful name. As a small summary for this, we have seen how to use LD preload. We need to have an absolute path for the library when we want to load. One can use libbfd to get shiny names, and there are many ways to generate a backtrace in your application. So if you want to have some kind of automatic crash report, you could handle SIG/SAGFold and use one of the ways to generate a backtrace and lock it somewhere in your application if you don't have a different or better way to generate cordons. And memprof is using all this and builds a UI on top of it. A small outlook, like if you're interested in using it or improving it, it currently doesn't work on ARM because we don't generate proper backtraces for it. We have a problem with custom allocators, as I told you. We need a way to fix it. And there's also, for the last couple of years, there's a system in development called SystemTab, which could allow user space tracing if utrace ever gets merged to the kernel, and memprof could be built on top of SystemTab to get this information, and this would also solve the problem of custom allocators, if I understand things correctly. And before I finish, we can go back to the actually memprof code to see that the stuff that I talked about is actually the stuff I'm doing we're doing in memprof. So we have 2 parts. One is like the lib directory, which has code for stack frame, which is actually yeah, it's not done by me, so I'm building on top of the work of others. So the first one here is just using glibc backtrace feature to get the backtrace. The next one actually knows about the stack layout on x86 and knows the place of the return address and starts with the first frame and then is walking the frame until the end of memory. Here, and if we don't have it, we just error in compilation. And mem intercept is the same. So as you have seen in the example, we have custom memory pointers, some special code for WebKit, and inside do malloc we see if we have initted ourselves, and then we call the real address. We remember which kind of abbreviation we did, the old pointer, the new pointer, how much we have allocated, and then we generate a backtrace from this place. And it's getting written over a Unix domain socket. And then in the source directory we have the usual GDK code to have a tree model and navigate through it. Okay, I know this was a lot in just 30 minutes, so do you have any questions or doubts, or did I lose you? Did you understand? Or
各位如果有问题的话，请踊跃发言。那发言前提醒一件事情，请先按一下你桌上那个开关，我们才听得到你的问题，好 ，Brighter 才知道你在讲什么。好，麻烦有任何问题的话，可以现在发问。啊，如果你觉得害羞的话，等一下 Brighter 还是在那边，你可以跑过去问他也可以。哎，那看现场有没有直接想要跟他做互动的。
Please go ahead.
也对，看起来讲者比我们还要害羞。好，我们可以教他一句中文叫“沉默是金”，因为我们现在大家表现都是黄金的样子。
Does the memproof support the memory debugging features? For example, the check if the memory is accessed after it is freed or is no?
Not at all. It just tracks allocations and allows you to see what was allocated.
Thank you.
Hello. Is it the front end of anything?
Sorry?
Is it the front end of anything?
It's either front of
Front end.
Front end. Do anything. Yeah, it's the UI. You can navigate through the allocations. It's it tries to resolve the symbols to names. Oh no, it's everything included. So the library is part of memprof as well.
Okay. Thank you.
How is the performance compared to other memory leak detector such as Filegrind or something else? Because we have to run memory detector on some heavy loading servers, so performance is an issue.
Yeah, I think the leak detection of memprof is not really working right now, but in general it's faster than Valgrind because it's not emulating anything but just intercepting calls. So if the leak detector would fully work, it would be faster than Valgrind.
Thank you.
这时候是要拍卖喊价的时候，第一次，还有没有问题呢？再来第二次，那我们要 deal 咯。那这时候我们要谢谢我们的讲师给我们一个这么精彩的演出，还有实作。那这时候应该，通常应该大家有反应啊，还是我要把这个，对 ，show your patience。那我们谢谢讲师。好，那我们也请大家稍微休息一下，我们也没有休息多久了，我们等一下下一位讲师过来 stand by。